So a little bit about this problem. It's not vital that you are able to replicate every single step here. I just want to make sure that you get the basic idea. So we're given basically what you see in this picture. ABCD is a parallelogram, and, well, sorry, it doesn't show that in the picture at all. And AC is congruent to BD, so the two diagonals are congruent. What we're trying to prove is that ABCD has to be a rectangle. Now, this is one of the rules you learn about rectangles, is that the diagonals are congruent. So we're not going to use that rule. Essentially, what we're trying to do here is prove that this rule is true using other rules that we already know are true. Deductive reasoning. We've got to prove our rule is true so we can use it. So we start off just knowing this stuff right here. Oops. Okay, now if you look at some of the rules that are used here, maybe a couple will stick out to you. So like side, 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 that's something we talked about a lot, not that long ago. Side, side, side is a way that you show that two triangles are congruent. And so our first set of steps here is going to be showing that two triangles are congruent. And it's going to be showing that by saying that their three sides are congruent. So we already have a couple of side lengths of something that's congruent. We've got AC and BD. Now those could be sides of triangles. If you think about like BDC as a triangle right here, the bottom right half of the rectangle, that's a triangle. And then AC could be the side of a triangle too. It could be like the bottom left half. That's a big triangle that has AC as a side. And so those could be two sides of two different triangles. We're comparing something like that. So we've got that those two diagonals are congruent. Again, they're sides of triangles. So are DC and CD. Now, how would I know that? Well, probably the reflexive property. What tells you that anything is congruent to itself. Specifically, the reflexive property of congruence. Sorry about the clicking. So here, I need to say that, so ADC. So I know that the hypotenuses of these triangles are congruent. I know that the bottom side of these two triangles is congruent. I need the third to say that the third side is congruent. In this case, AD and BC. How do I know that? Well, because I know this is a parallelogram and the opposite sides of a parallelogram are congruent. Now, I can't do the notation here, but I would say that AD is congruent to BC. And I know that because they're opposite sides of a parallelogram. And that's a rule. So now I've got side, side, side for two triangles. So then I say that ACD and BCD are congruent. So triangle ACD is congruent to triangle ACD BDC. Would be the correct order to put those in. How do I know that? Side, side, side theorem. Well, if those two triangles are congruent, then angles ADC, which is this one right here, and angles BCD are supplementary. So this is another rule in parallelograms. So ADC, BCD, they're two consecutive angles in a parallelogram, therefore they're supplementary. What's that rule called? Something about the consecutive angles of a parallelogram are supplementary. Cool. So again, that's a rule. So we know that these two angles have to add up to 180. Keep in mind what we're trying to show is that this is a rectangle, meaning it has four right angles. So we're trying to show that these two things are right angles. We said they add up to 180, so it could be 90 and 90, but it could be 91 and 89 or something like that. How do we know it's specifically 90 and 90? We know that because angle ADC and BCD have to be congruent to each other. Why do they have to be congruent to each other? Because they are congruent parts of congruent triangles. Therefore, they're congruent. Congruent parts of congruent triangles are, corresponding parts of congruent triangles are congruent. So ADC and BCD are in the same spot on those two congruent triangles. Therefore, those angles have to be congruent to each other. So if they add up to 180 and they're equal to each other, then they have to be 90 and 90. So angles, whatever that is, ADC and BCD are right angles. And then you basically just follow along with the same logic from there. So the opposite angles in a parallelogram are congruent to each other. So this has to be 90, and that's got to be 90. And hey, look, all the angles are 90 degrees. So that's about it. Again, you don't have to be able to reproduce this from scratch. Hopefully you understand the basic idea that we're using here.